Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Well, welcome everybody again to another episode of our show, bringing you another really fascinating guest today who is helping to create a better tomorrow on many different fronts. We have the honor today of being joined by Dr. Joel Mozer, who is the Director of Science, Technology, and Research at the United States Space Force. With a PhD in physics and a master's in atmospheric sciences from the University of Arizona, Dr. Mozer serves as the principal scientific advisor to the commander and is the senior authority for all science and technology matters of the organization, which has approximately 11,000 space professionals worldwide. They manage a global network of satellite command and control, communications, missile warning, and launch facilities. In this role, he interacts with various other principals, including operational commanders, combatant commands, acquisition, and international communities to address various cross-organizational science and technical issues and solutions. Dr. Mozer also represents the United States Space Force Science and Technology on decisions, high-level planning policy, building coalitions and alliances throughout the United States, government, industry, and academia, as well as the international community and other scientific technology organizations. Dr. Mozer entered government service back in 1992 with the United States Air Force. Prior to his current assignment, he was the chief space experimentalist of the Air Force Research Laboratory, a Space Vehicle Directorate. He has more than 30 years of space science, engineering, management, and financial experience working for the DoD. In addition to the Integrated Experiments Division, he serves as the Chief of Battle Space Environment Division and led the Laboratory Space Weather Center of Excellence and was a scientist as well at the National Solar Observatory in Sacramento Peak. Before arriving at the Air Force Research Labs, he worked at the Air Force's Radar Attenuation and Scattering Facility at Holman Air Force Base, developing measurement and analysis techniques to study radar cross-section of low observable aircraft technology. And prior to that, he worked for the Army's Atmospheric Sciences Laboratory, developing various techniques to quantify the effects of both natural and man-made battlefield obscurance on electrical optical sensors. Needless to say, a very cool and scientific guy, and really glad to have him with us. Dr. Joel Mozer, thanks so much for taking time to come on the show.
Well, thank you, Ira. I'm honored to be here, and it's a pleasure to speak with you today. This is fun stuff, and sorry the bio is such a mouthful.
No, I always enjoy bios like yours, and introducing the audience to everything you've done. But I'd love again to start out, as we typically do, by handing you the floor for a little bit, just to talk a little bit more about yourself. If you could take us back to the early story, things like where you grew up, how you developed these interests in physics and atmospheric sciences, and a bit of that early journey that got you interested in this whole area. Please take the floor.
Oh, thanks, Ira. I'm a nerd deep down, and always have been. I enjoy science, and really the reason I think it's so enjoyable, and I think lots of kids get this, that it's a big mystery of how things work, how things came to be, and that can be across all kinds of things, like why does the sun shine and why does it feel warm, to why do people think the way they think and do the things they do, and why does things in nature behave certain ways. And so that's always fascinated me, and it's really about digging through the data and trying to understand how things work a little better to get behind those mysteries. And it's always amazed me that how, in the big picture, how little we really understand about Mother Nature. There's just so many things out there that are fascinating subjects, and the more you dig into it, the more questions that get asked, and the more interest you can develop in digging further. So I've always loved that, even from a kid. And I think we need to encourage that in kids, to ask questions and to seek this kind of curiosity out. Unfortunately, I think we tend to beat it out of them sometimes, and send them off on maybe more practical endeavors in somebody's mind. I don't know, but that's really my background. And you mentioned, a lot of things that, especially in my early career, were related to atmospheric sciences. And in just to be specific, one of the things that got me in that field is I just happened to have a really excellent teacher in high school, and then another professor in college, and I took a cloud physics class just because clouds are interesting objects. I had no particular reason to do this, but it sounded like an interesting class. And again, the more you learn about how clouds are formed and the very intricate physics and chemistry and dynamics that go on there, it just gets more and more fascinating all the time. And there's a particular problem that often gets talked about is a rainstorm. In order for a rainstorm to happen, you have to start with water vapor in the atmosphere, and that has to condense on a little tiny cloud condensation nuclei. It can be a micron or two in size, and that water vapor will condense on that, and that cloud droplet will grow to a few tens of microns, and pretty soon it might be what you would call a raindrop. If enough of them get together, it takes millions and millions of these to happen at once and come together, and then it'll rain, and you get millions of raindrops out of a single cloud. And for all of that to happen, we think we understand the basic physics, but to model that and to understand from a first principles mathematical sense how all of those things come together to create a rainstorm, we're not quite there yet. We don't understand all of that. We can't do that. And that's that's an example of just the fascinating stuff. So that interest grew, and ended up studying the development of hurricanes, actually. So understanding, in particular, off the west coast of Mexico, how hurricanes form there and their interaction with the topography, and because there's a lot we don't necessarily hear about those as much as we do as Atlantic hurricanes, because they tend to just go off in the Pacific. But understanding the physics, and again, why do these things happen so often, was just fun stuff. And that led me to a career in the Air Force, worrying about numerical weather prediction and support to Air Force warfighters, because the Air Force operates and flies in the atmosphere, so we ought to know something about it. So thankfully, they invested a lot of energy in that. And then eventually my curiosity ran into space, and I got very interested in space physics and the operations of instruments to monitor the space environment and to try to predict solar storms and geomagnetic storms. And that's what led me to spend some time at the Sacramento Peak Observatory, doing what your mother always told you not to do, stare at the sun all day. Just fascinating stuff. Even more questions get raised about that, and eventually moved on to actually worry about more of the spacecraft side of things, and actually developing and flying space experiments to take data about the environment and other things. And one thing led to another, and here I am in this new Space Force, which is just over 2 years old. There's still a million questions to be answered from a scientific perspective, and one of my roles in the Space Force is to try to continue to instill that curiosity and technical depth with our Space Force guardians, because understanding the environment and the systems and the capabilities that we operate in is a part of doing that professionally and being good at what we do. So that's kind of my job.
Excellent. And Angel, I'm sitting here now in downtown Philadelphia, but I used to live outside of the city near Willow Grove Air Base. I would see airplanes take off from there, and I could look up in the sky and see the Air Force. I've been at Kennedy Space Center. You can see rockets go off there and see NASA or SpaceX nowadays, whatever. And then I also had, talking about hurricanes, I had Frank Marks on a show about a year ago. He talking about flying his hurricane hunting airplanes into the eyes of storms and so forth. So I sit here and I look up in the sky. Talk about where your domain in terms of Space Force exists up there. And I'm sure there's a bunch of overlap and so forth. But talk about, introduce us to U.S. Space Force in sort of the last 2 years, and also sort of where up there is your domain.
Yeah, that's a very good question, and not a trivial question either. And it might sound like it is, but it is not. So we do. So first of all, I should say the Space Force is just like any other military service branch. We don't actually conduct warfare. We don't fight wars directly. That's all happened by the Joint Combatant Commands. We organize, train, and equip those forces and present those forces to the combatant commands. And in the case of space, a primary combatant command that we present forces to is United States Space Command, which is currently headquartered here in Colorado Springs. And that's where this question you asked really gets focused, is so they are a combatant command that has to work with other combatant commands to conduct operations. So for example, if we do have to go to war somewhere and there's a component of it that space services are needed, then it's the United States Space Command that supports that through satellite communications and GPS and things like that. So when they were standing that up, there's two different kinds of combatant commands. There's functional combatant commands, like Transportation Command is all about airlift and mobility and getting stuff from point A to point B. That's a functional command. And then there's regional commands like Indo-Pacific Command or European Command. Those are around regions. So the question was, similar to what you just asked, is it a functional command space or is it a regional command space? And there's a lot of debate and discussion about that. And in the end, it turns out we went with an area, a regional command. So we do have a region. It's a region of space. And it starts 100 kilometers above your head and goes to infinity.
Infinity. It's pretty far.
That's pretty far. And so that's kind of helps organizationally with how things work and making sure the combatant commands are seam together. And obviously, most of our activities are either in low Earth orbit or in geosynchronous orbit. So, a few hundred to 30,000 kilometers out. We're starting to think about what our role is going out to the moon, to the orbit of the moon, what we call cislunar space, because there's just more activity, human activity there that we need to be aware of. And someday, if humanity goes to Mars and beyond, we will be there ready to follow. So because we're 100 kilometers to infinity, we have that domain.
There you go.
Very good question.
I appreciate that. That gives me some, that gives me some perspective, and it's a pretty big domain. So that's cool. That's really great. Joel, in August 2020, Space Force published their capstone doctrine, Space Power Doctrine for Space Forces, and in this it lists a bunch of the different research domains that these 11,000 folks that you oversee sort of are going to be working on. Touches on a bunch of really cool areas: space domain awareness, mobility, information mobility, space security, of course, and so forth. I know this is the broad question. I usually give it to everybody in the show, but Dr. Joel Mozer, you come in the office in the morning, you make some coffee, you hang out at your desk. Talk about how you decide what you're going to work on in any given day in all these research domains. How does this all work? If you would sort of go into a little bit of sort of your day-to-day activities in running research.
Yeah. If you have some good answers from some of your other guests, send them to me so I can figure out how to schedule my day. But
everyone drinks coffee in the morning. I never had anyone.
Right here. Yeah, so the one interesting thing about space that I like to point out to folks is, um, you know, the Space Force is relatively new. We've been operating in space. The first Gulf War in 1991 was really the kind of the first indication that space was enabling the way the Americans like to compete in wars, which is on the other side of the globe, remotely, and so we provide a lot of the communications and the precision navigation that allows that to happen. Um, and that's that's kind of grown over the time, and certainly it's become foundational to the way the joint forces work. But and there's this issue that we kind of turned away from that while we were worried about the global war on terror, and other nations kind of recognized that space was very important, so they started looking at ways to deny us that capability, to put our space assets at risk. And so now we're in a position that we're very much worried about how to make those capabilities resilient and able to operate in the fog of war and all those things. So that's one piece of you can kind of infer some of the science and technology that
Sure.
might be involved there. But from where we are today, going forward, there's kind of two things that are growing in space. One is the dependence on space capabilities on our joint terrestrial forces, or by our joint terrestrial forces. So, we only need more communications through space. We only need higher precision navigation and precision strike tools. We have more UAVs that are flying. We need things like tactical intelligence, surveillance, and reconnaissance from space, where we can conduct things from space that we haven't done before. So that kind of component of the Space Force that is supporting the joint terrestrial fight, the demand signal is just going up, and there's a lot of technology that needs to be developed, a lot of game-changing things that we need to find new ways to do things. So, for example, instead of flying an AWACS that could be shot out of the sky, how about we put that battlefield command and control up in low Earth orbit and do, so there's lots of talk about that. So that's one thing. The other thing is space is an area of human endeavor is also growing. I have the speech I give about how we're in the golden age of space. We have all of this really cool activity. NASA's going back to the moon. We have billionaires investing in space for everything from space tourism to global internet to mining the moon and Mars and human exploration and habitation. So those of us that are space enthusiasts believe pretty strongly that space is really coming of age now.
Mm-hmm.
And 20 years from now, we're going to look back and say, yeah, 2022, that's when things really took off in space. So the problem for the Space Force is, one of our missions is to protect the U.S. interest in space. And
Yep.
as those interests grow, so too must our ability to protect them. So we in space kind of have this, because we're a growing and immature domain today, have this two-pronged problem that we have to grow to support sort of our traditional way of doing warfare, but also prepare to do this bigger picture strategic stuff. And so that's kind of the problems I have to face every day when I come into work is, well, first of all, I think I'm pretty clear in stating that to do both of those things would require way more resources than we have, and even the Department of Defense budget and national budget would allow. So we have to pick and choose where
Mm-hmm.
we can grow. And so in some cases, we're going to have to take risk in one of those areas to develop the other. So for example, taking risk in the present to make sure that we're investing in the ability to maneuver through this cislunar space out through the moon that we don't have a requirement for today, but we probably will in the future.
Mm-hmm.
Or vice versa. So maybe we would take risk in the future to cover some very important concept today. So it's really, my day-to-day job is a constant look at those kinds of technologies and really trying to strike an optimum balance between making sure we cover down on the most important things today, but don't forget about investing for the long term in things both geopolitically and technologically and are going to change, and we need to be prepared for that and actually lead that change. And so that a lot of that is investing in the basic research that might enable things in the future to make sure that we have scientists that are covering down in fields like quantum computing or quantum sensing or artificial intelligence to make sure we can apply those technologies to our systems, but also to make sure that we're not surprised by somebody else, our strategic competitors,
Yeah.
getting ahead of us in any of those areas and using it against us. So it's a constant battle and fight to make sure that we're covering down across a pretty broad waterfront of things to do.
Absolutely, absolutely. And one of the fascinating things that talking to thought leaders like yourself, Joel. When I look, obviously I come from the life sciences, but I'm always impressed by all sort of the dual use opportunities. Obviously, you have that domain to take care of up there, but there's so many things that sort of trickle down. And you gave a couple talks that I just like to highlight and get your perspective on at the Air Force Research Lab Inspire talks. Last year, one of these was entitled How Technologies of Today Are Creating a Superhuman Workforce of Tomorrow. And you get into different areas, augmented reality, extended reality. In the classroom, I had the honor of talking with Dr. Sharma and Bridges from the 7-Eleven Human Performance Directorate last year, talking about their iNeurals technology, this really cool sort of neurotech that can enhance the ability of pilots. And they also mentioned Space Force. You can teach somebody to fly a space shuttle faster and so forth. Talk just in general about your interests, your personal interest in human enhancement and some of the potential dual uses of these technologies. I would say, you hear Elon Musk on TV talking about going to Mars, but I say, is he working on, all the health matters and, the growing of the food and all that other stuff besides the rocket ships? Talk a little bit about that, if you would.
Well, yeah, and my interest there is looking over time that, we've had this industrial age where we've developed machines and tools and the ability to mass produce things. And then we had the information age where really data and ability to understand things from a data perspective and to get things done through information. That was the information age. So these things have existed for a long time, but we're getting to the point where the real fascinating area of the evolution of mankind now is this: how do we interface with machines, and how do we use that technology to augment the things that we can or need to do? So some people call this the age of human augmentation, but we've been augmenting ourselves with tools since the caveman days. It's the first time we picked up a stick, but it does seem like that we're at a point in history where the opportunity space for augmenting our capabilities through teaming with machines is just kind of unlimited. There's just so much that could be thought about there. And humans have their shortcomings and machines have their shortcomings, but together there's some pretty interesting things that we can do. So I'm just personally interested in, again, because I'm curious how things work and how things could be, about what the potential is there. And I'm particularly interested in how machines can help people learn better, and so that's that can be anything from just coming up with better instructional techniques using technology to virtual reality or augmented reality, to some sort of human machine interface that allows the human brain to be more effective and efficient is very it's fascinating stuff, and the potential is great. I was just recently we're developing a lot of relationships with universities in the Space Force because we need their help. And one of the places I visited recently was Arizona State University, and they have a big emphasis on virtual reality and augmented reality in pedagogy and in teaching.
Okay.
So, for example, some of the harder subjects that may be seen as barriers to people pursuing science and engineering careers, things like calculus or advanced math, sometimes is a barrier that people can't get past.
Yep.
But by using virtual reality and techniques like that, you can visualize and get inside and understand at a very intuitive, conceptual way how some of that mathematics really works, and develop an understanding that's just way better than what you could get by reading a book and sitting in some lectures and doing some exercises. And so the potential there is to remove that barrier from folks. So people who have an interest but just can't get past those technical concepts, using better human-machine interactions, get them past that, and just imagine what could happen from there. You bring in great creative minds if you can do that. Those are the kind of areas that I'm very interested in.
And along those lines, another one of these talks that you gave, and you mentioned artificial intelligence before, was entitled Trusted AI at Scale. And you mentioned some very interesting things in this talk. You talk about how Space Force was, in quote, born digitally. You know, it's rather new, and it comes into this world with all this really cool digital stuff, as you were just mentioning. And then you were also talking about that, you know, once again, I can go outside, look up in the sky. It's nice and blue. I don't see too much stuff, but there's a lot of stuff up there in orbit, whether it's Elon Musk's little satellites or debris or whatever from the last however many decades we've been putting stuff up there. And talk about tools like artificial intelligence and how they ultimately help you, you know, sift through the clutter of what's what and help guide your research.
No, that's exactly right. And you know, the Space Force is all about, really today, information. It's, you know, we provide conduits for satellite communication. We provide the imagery from space. And position navigation and timing. We provide that data to users on the ground. So we are very much a digital or information-based service. You know, the Army fights with rifles and the Navy with ships. We fight with bits and bytes. That's just what we have. And so the application of artificial intelligence to that, all the data that we deal with, is kind of a no-brainer. It's something that we should do. But you know, and there's other aspects of space that make it kind of a natural fit with artificial intelligence, and that's that we are operating machines remotely. You know, they're in space flying around, and they have to do their job, whatever it is, and sometimes they may need to be autonomous and to make decisions on their own. So, you know, sort of the, you know, satellites could be considered robots in space, and so AI kind of matches that.
Mm-hmm.
And then, you know, there's practical problems like you mentioned that you look up and there's lots of things up there for sure. And, you know, one of the roles of the Space Force is to catalog all of the objects that are in space, you know, so that we make sure they don't run into each other. And so, you know, we take 300,000 observations a day from ground-based systems of satellites in space, and we have to identify what we're looking at, because it's just a little dot in the sky, and then we have to put it in a catalog to make sure we know where it's going to be and whether it's going to get in the way of something else. So that's a lot of data, and right now that's done in a somewhat human-intensive process where we have operators sitting on the floors of our operations centers, taking all that data in and processing it. And that's, first of all, a hard job, and we need automation because the number of objects in space is just going up ridiculously. We're having more and more things to look at. In applying AI and automation to those operators' jobs is another area that's of high importance to the Space Force, so we invest a lot in that. And of course, whenever you're talking about a military system as something that could be used in time of war, you got to have a lot of trust in those things too. It's a little bit different than your Amazon Alexa that's recognizing your voice,
Sure.
or doing your phone that's doing autocorrecting. There's some room for error in those things. But when it's a no kidding military system where you may be communicating with a lethal system, you really need to add higher levels of trust to that, as well as the sort of the ethics and morality of what you're trying to do autonomously. So we have sort of another level of layer of AI kind of concerns that we have.
Sure. Excellent. Joel, before you mentioned, you're doing a lot of partnerships with the university labs and so forth. What is the typical, opportunity for whether, I'm hanging out in a university lab, or I'm at a startup company with a couple of people that, I've invented half-speed light travel, or I'm coming up with something new and interesting. What's the process of partnering with Space Force today?
Yeah, so there's lots of avenues there, and my office is one of those avenues. And we, just to talk about universities for a second, one of the things that the Chief of Space Operations, General J. Raymond, and the Vice Chief, General D.T. Thompson, decided very early on in the stand-up of the Space Force is that because we're so small and so lean, we're like you said, about 11,000 folks headed to about 16,000. Compare that to the Air Force, which is 600,000 folks. We're small and lean and agile. But so they recognize that we need to partner with universities, because there's a lot of intellectual capital, a lot of brain trust in those universities. A lot of which has grown up with the space age, in partnership with NASA and other entities. That there's a lot of capability there, and we need to harness that. And we just need, because we're so small, we need that help in thinking through the tough problems, thinking through the technology that's coming our way, and how we can apply it and how we can use it. So we created something called the University Partnership Program, UPP, for the Space Force, and we have a little more than a dozen schools right now across the country that we're in deep conversations with, not only from a science and technology perspective, but also in a training, workforce training and recruiting for folks for the Space Force, but using the universities kind of to help with that. In a lot of the need for that is around maturing new ideas. So some researcher at a university may have a concept for half-speed light travel, like you say, and we would be interested in that, but it needs to be developed and matured and transitioned to solve some of our problems that we actually have through our programs of records or acquisition systems, and that's where businesses come in. And that's another exciting thing about space in particular is, kind of fueled by the big billionaires investing in space. There's a lot of new space startups, folks who are out of their garage thinking in new ways to do things and new concepts and technologies. And that's exciting stuff. And it's a challenge for us to get our arms around all that really interesting thought and direction and new work, because the private sector investment in space is easily 10 times what the government investment in science, space research and development is right now. So there's a lot of that happening, and we need to take advantage of it. And so through our university partnership, and also just working with these startups and venture capitalists and new space entrepreneurs, trying to understand what their capabilities are and where they can go and how we can use that to achieve our mission is a big challenge. And I welcome people to get in contact with my office if you have an idea, if you have half light speed capabilities, I'm willing to talk.
I don't have it yet, but I have some stuff on a cocktail napkin over here. No, it sounds like a fascinating, space tech ecosystem that's developing. Obviously, we see what we see on TV with all these different parties coming together. It's really a fascinating time for you. If we go a little earlier, sort of now the generation after the current folks in the university labs, the younger generation that's listening and wants to become part of this. What's some advice for that next generation? They're listening. They want to be the next Dr. Joel Mozer. What do you tell to the kids that are just graduating high school now? What should they be studying? What should they be looking into? A little STEM advice, if you would, for my sons and and everybody else in his class.
Yeah, well, it's a very exciting time in embrace the rapid technology development. When I was coming out of high school, going into college, the internet was really just blossoming. There really wasn't much there, but it's grown over my career, and I just can't imagine the things that are going to grow from somebody who's leaving high school or college today. The things that they're going to see in 20, 30 years are just going to boggle the mind. And we can't even anticipate some of those things. Our mind thinks linearly, and things develop exponentially, so we just can't do it. But it's exciting, and my advice is, stay deep and current, and if you're interested in these kind of technology careers and doing science as a career, then go for it, because the opportunities in that are just going to be amazing and growing quickly. And innovation is a funny thing. People use the innovative word all the time, but to me, innovation means taking technologies or science or phenomenology and putting it together to solve problems. So there really has to be a problem to solve. And so my advice, and I wish I had known this when I was young, is think about the problems that can be solved and pursue them. Put some brain power behind it, and pursue fields that allow you to get at that problem. And the other sort of a generic piece of advice that I wish somebody would have told me is there's a difference between information and data, and just being having a collection of a lot of facts and figures in your head, and having so that's kind of development of knowledge. A bunch of stuff, but that's not wisdom. Wisdom is taking all that together and finding a way to apply it in a certain way. So, don't get hung up on the knowledge part of it. Seek the wisdom part. Try to get to the point where you're integrating all of that knowledge and data in changing the world, because I think the world is going to change dramatically over the next coming decades. It's an exciting time.
Definitely is. That's why we love talking to thought leaders like you, Joel, because you're in such the sweet spot to see it all coming, and you're crafting it. You're putting it together for all of us. So it's such an exciting time, and I really take my hat off to you for everything that you have going on. One final question. Here we are in the sort of the wrap-up point of the show. Got to ask. I asked this before. I'm going to modify this question slightly, but Joel, you had a long, hard day at the office. You come home, you have some dinner, you relax on your sofa, you turn the TV on. Does Dr. Joel Mozer ever watch anything, movies, reality shows, anything that has to do with space or aerospace or aliens or anything of that? And what do you do to relax? Just if you don't mind me asking.
Oh, absolutely. Well, first of all, yes, I'm a science fiction junkie and love that. I love reading, and I like going back to my introductory comments about just curiosity and following how things work and how, continuing that. So I am a science nerd at home too, and I love reading about latest discoveries and doing that as well. The other thing that kind of maybe counteracts all of that, that sort of leading edge, trying to stay on top of stuff, is I concentrate on trailing edge technology. That is, I love to restore old cars, old machines, old things, and and part of that is an appreciation for where we've come with technology.
Yeah.
So, I have several 100-year-old cars, and they're very simple and simplistic, which is why I can understand how to do something with them. And just to put your hands on something that came from an earlier time when we didn't have all this technology and understanding, and just it gives you an appreciation for how far we've come, and to me gives me an appreciation for how far we're going to go, because again, we're not following a linear path, we're following an exponential path. So it's just amazing what's going to happen. I fully believe we will have half-life speed travel in a very short number of years because of that. So it's just exciting.
Yeah, that'll get us closer to infinity,
Right.
or near to it. So, yeah, no, great stuff, Joel. I mean, it's once again, it's really fascinating, and I'm rooting you and the 11,000 or soon to be 16,000 of your folks on for what's going to be coming, and you guys crafting it all, and really, really great. For everybody that is going to be listening to this episode of our podcast or watching on the YouTube channel. Once again, you've been listening to Dr. Joel Mozer, Director of Science, Technology, and Research at the United States Space Force. Joel, I want to thank you for taking the time out of your schedule to come talk to us for a little while. Obviously, thank you for everything you're doing. And as we say on this show, thanks for helping to make a better tomorrow for all of us through your work. Really, really fascinating story.
Well, thank you, Irene. It's an honor to speak with you, and I appreciate the invitation to do so. So thanks for all you're doing as well.
Great seeing you.